Hello everyone and welcome back. So we are going to continue from where we left in the previous session. So in that session we talked about data validation. So in this video we are going to be discussing about the data transformation. So again we are going to start with the configuration of files. So under the config.yaml file, we are going to create a new stage, and that is the data validation. So this will be data transformation stage. So under config.yaml, so let's create the data transformation stage. So data transform is the data transformation. Under data transformation, again, we'll be creating a root directory specific for data transformation. We're going to create a root directory. So root directory, then will be in the artifacts data transformation. Root directory, artifacts, data transformation. Then we are going to specify the data path. So data path, where we are going to get our data. So data will come from the this is our data path, artifacts data ingestion, this one here. This is the data path. Also we are going to specify both the numeric columns and the categorical columns. Again, I'm just going to specify those. So we specify the numeric columns, so we give a list of the numeric columns in our data, as well as we give a list of the categorical columns in our lists. Okay, so you will see how this, because the way we are going to manipulate the numeric columns will be quite different from the way we are going to do the data transformation for the categorical columns. So feedback, then we need to add another column, a medium of operation, I think that's okay. So this is the configuration, details for data transformation. Okay, then we are going to switch to trial number 3, data transformation, and then we are going to start writing the code for data transformation. So as usual, we do start by importing the necessary libraries, for example, pandas, numpy, os, all that. Then we also import the logging, these functions from utils. Then we also import this as from the constants, these configuration files. Then we also import from scikit-learn, we also import these libraries: train test, split, column transformer, pipeline, simple imputer, and the min-max scalar. So as we progress by, you will see how these different libraries will be applied. So we create the entity class. We start with the data transformation entity. Data transformation entity. Then we create a data class. So at data class, then create a class, a data transformation config, data transformation config. Then from here, remember, we are just going to list all this: the root directory, numeric columns, as well as the categorical columns. So under this, we're just going to list whatever we provided in our a configuration.yaml file. So this one will be path. Then we also describe this as a path because we are giving the path to our data. So this is the path. Then for the numeric columns, we are providing a list, supposed to be a list. But also for the categorical columns, again, here we provided a list. This is our data transformation entity. So we move to the configuration, create the configuration manager. So data transformation configuration manager, data transformation configuration manager. Then here, as usual, so if we go back to our data validation, some things just remain constant. We don't need to rewrite them over and over again. So for example, this is a constant. We can just copy this data, go back to data transformation and paste it here. So a configuration path. Then we are reading these YAML configuration files to initialize the configuration parameters. So that's okay. Then we create directories specified in the configuration. Then from here, we need to create another function that will going to do this operation. So that is the get data transformation config, self data transformation configuration. Then from here, essentially what we are doing with this is that let's write the code, then I'll just provide an explanation as to what I am doing. Then we are going to get the data transformation configuration. So that is config self config data transformation. So this one will be copying the data from the config.yaml, this one here. Okay, so that's it. So it will be going to it will be reading data from this configuration, this configuration.yaml config.yaml file. Then we are specifying that look at the stage data transformation and read and return whatever we have provided under the data transformation. So that's it, this one here. Then from here, we need to create directories. So it's directories. Then we specify config root directory. So root directory, so that's okay. Then from here, we can just create and return the data configuration object. So data transformation config, that one is okay. Then the root directory, data path. These are supposed to be path. Even this one should be a path. So path. So we need to specify that this should be a path. So config path. So config root directory, and path config data path. And this one should be a list, similar to what we did earlier. So this will be a list, and this also again need to specify that it should be a list. So list, that's okay. Then we need to return the data transformation config. Okay, so under the data transformation configuration, this is under the configuration manager, and it's under this, the data transformation config is responsible for retrieving the configuration parameters that we have specified in the different YAML files, and also creating the data transformation object, this one here. The one the data transformation object, because we are creating and returning the data transformation object. So the method starts by it will be start by accessing the data transformation configuration, these files here, the YAML files, and then it creates the necessary directories, the root directory, because we are in the data transformation. We'll create of another folder under the artifacts. That folder will be the data transformation, and it will store the artifacts under the data transformation. Will be the training set, the training and the testing set data. Also the target column. Okay, so that one will be housed under the data transformation directory. Okay, so after that, we need now to create a class to handle the actual data transformation process. We are going to create a class to handle the actual data transformation process. So class, we are going to specify a class data transformation. A class data transformation. We define a function def __ init self config data transformation configuration. Then now we call it back. That's it. Then now we create the first function under this we are going to create will be to get the data transformation object. So if get transformation object, get transformer object, object. So this one here. So self be the parameters will be the X train and the Y train. Then we create the try block. The try block, we're going first, we need to separate the numeric and the categorical columns. So under this, you're going to separate the numeric and the categorical columns. Categorical columns, so numeric columns. We'll just call this the numeric columns. So we are calling the numeric columns. So remember, we provided a list of the numeric columns as well as the categorical columns. Then after this, we need to create a pipeline for the numeric columns. So create a transformer for the numeric columns. So numeric transformer, that is the pipeline steps. So for the numeric columns, you can see we are using the imputer. So we are imputing using the strategy median. So if in any chance that one or our columns has some missing values, then under the data transformation, we are going to impute or replace those missing values using the median value in the respective columns. Then after we are done with that, then we can scale our data using the min max scaler. So that is the thing we will use. Let's use a pipeline. This is we are creating a pipeline for the numeric columns. Then after that, we create another pipeline. So since we are using the target encoder, let's create a target encoder instance for the categorical columns. And for this one, I don't think that we won't be scaling when using the target encoding. So for the categorical, so we'll call it categorical transformer, then a pipeline. Then under the pipeline, we list our steps. So the first will be, I don't think I will use, should we use an imputer? Simple imputer, yeah, no problem. I think we can use again, if you are missing values, then we can impute with the strategy constant. Should we change the strategy? Let's see. In terms of the strategy, strategy can be the mean. You can see can be the mean. Missing value, okay. Okay, you constant mean. Should we anyway? No problem. Okay, just leave it as that. Then target encoder, we can use the target encoder. Then specify the categorical columns. So let's see if this will work. Smoothing 0.1, minimal samples, handle unknown, ignore. Can also input calls, then we specify the categorical columns. Then these are just the other arguments that we are passing in. Okay, so then we need to combine the numeric pipeline as well as the categorical transformer. So we'll combine the two pipelines. Combine the two pipelines. So we'll call a preprocessor, column transformer, then the transformers, the numeric transformer as well as the categorical transformer. So then also under this, I'm going to specify that a reminder to be just states reminder. This one will just use pass through. That's okay. Then after this, we need to fit the preprocessor with the X and the Y train. Okay. So we are going to fix the preprocessor to the training data. That's okay. Fit the preprocessor with the X train and the Y train. Preprocessor.fit X train Y train. Then at long last, we return the preprocessor object. So return preprocessor. Then remember we were encapsulating this in the try except block. So we complete this with the except block. So the except block can just say exception as E, then raise E. That's okay. So with the get transformer object, essentially what we are doing here, remember that this function is responsible for creating the data transformation pipeline, and this pipeline includes majorly the two main steps: the numeric column transformation. So the numeric column transformation, you can see this one here. Under the numeric column transformation, we first start by identifying the numeric columns. Then we create a pipeline. This one here. This create a pipeline of the numeric columns, which includes two steps, which is the imputation. So the missing values are filled using the median strategy. And after that, we scale using the min-max scaler. And for the categorical columns, again, we start by identifying the categorical columns. Then after this, we create the categorical pipeline. And under the pipeline, we have the target. We again use the simple imputer. Then under the target encoding, the categorical values are encoded using the target encoder, as we have specified here. The target encoding replaces each category with the mean of the target variable in that category. Okay, so that's the categorical encoder. Then after that, we combine the two pipelines into a single using the column transformer. This one here. This object applies the respective transformations that we have specified under the two pipelines. Then after that, we use the fit. So we are fitting this. We are fitting the method of the column transformer to the training data, so X train and the Y train. Then finally, we return the fitted column transformer object. We return the fitted column transformer object. So that is the preprocessor. Then after this, we need to split the data into the training and the validation, as well as the testing sets. So we are going to convert that to the training testing and validation sets data. So just ensure everything. So after this, we split the data into training, validation, and the testing sets. So I'm going to create a new function here, def splits. So I just call this train val test splitting. So training, validation, as well as test splitting, train val test splitting self. So I think this one will be unnecessary. Self, so that's okay. Then just again create the try block. So first we can create a login information. So login.info. Then here we specify data splitting process has started. So data splitting process has started. So data splitting process has started. Then we can say df, get a variable df. So ed dot read csv, importing our data. So self dot config dot data path. So we are from the data path, this config, we are accessing our config.yaml file. From there, it has the configuration details for how we are going to access our data. Then from that, we'll split our data into the x and the y. So df dot we're going to drop the target column. So target column, that will be the churn risk score. So I'll just specify this to be churn risk. So that's our target column. So we need to drop that from our input features. So for the y, that will be now the churn risk score column. Then after that, we can again some logging information. So logging dot info. Then here we can say that splitting that now we start the process of splitting data into training, validation, and testing sets. So and say xtrain, xtest, x remainder, y train, and y remainder, because I'm splitting into 3, so training, validation, and testing. So the first instance we are going to split, I think we are going to split for training set, and the remainder we are going now to split that into validation and the testing set. So this will be x validation, and then this will be x val x test, then y val y test, y validation, y val, then this one will be y test. Yeah, I think that one is okay. So x train, x remainder, y train, y remainder. So train test split x and y. Then test size should be 0.3, random set of 42. So from here we are going to split such that 70% of the data will be used for the training set. So we are specifying that the training set, so the training set will have 30%, 70% for training and 30% remaining. Then we split the remaining 30%. we're splitting that into half. We split that into half to half, so 0.5. So 15% for validation and 15% for testing. So I just hope everything is okay under this. Yeah, everything is okay. Then this logging info, saving the training, validation, and the testing data in artifacts. So essentially, since we are going to perform further transformation on the training features, so I'll just be saving the target variables only. So save the target variables for each set. So the y train, y val, and the y test. Then now we can gain another logging information. So data splitting process has completed. Then from here we need to return the x train, the x val. We also need to x test. I think x train, x val, x test. Then y train, y val, y. Then y train, y validation, and also the y test. So that's okay. Then except block. Then and this is the exception as e, raise e. Exception as e, then raise e. So that's okay. So that's our training test. More clarification on this is that this function, the train val test splitting function, is responsible for splitting the data into the training, validation, and the testing sets. This is very important in machine learning because it helps to evaluate the performance of the model. So after we are going to explicitly train our data on the training x train and the y train. Then after we are done with that, we are going to evaluate our training data using the validation, the x val and the y val. Then we will do a model validation now using the x test and the y test. So okay, so the next step, we are going to initiate data transformation now on the training, on the input features. I'm going to create another function, and this will be this will be the function. So yeah, this one here. So yeah, I'm creating a initiate data transformation function. Again, I'm going to try block. Let me make sure that everything is okay. Yeah, this one alignment I think is correct. The alignment is correct. Yeah. That's okay. So we are setting up select the initiate data transformation. This method is responsible for performing the data transformation process. It will include steps like so let's start by logging at some information. Data transformation process has started. Then we get the preprocessor object. This preprocessor object will be coming from this one here. So whatever we listed under this, so we are getting the preprocessor object, and we are going to apply that object to our this data. I think it will be only the input features, so xtain, xval, and ytest alone. So we are going to get the transformer object. So getting the preprocessor object by calling the get transformer object earlier on. This method creates a pipeline for the numeric and the categorical columns, including the imputation processes, the scaling of the numeric columns, and the target encoding for the categorical columns. So from here, so we are first getting the transformer object because we are going to apply this the transformer to the training, validation, and the testing data. So xtain transformed, so we are applying the preprocessor on the training data. Again, you are applying the same preprocessor to the validation. Maybe just include that. So preprocessor objects supposed to be preprocessor object. Let's make some changes. So preprocessor object, preprocessor, yeah. So we are going to transform the training, validation, and the testing data. And we are just doing this by calling the get transformer object. So that function. Then now we need to save the preprocessing. We need to save the preprocessing object. So saving the preprocessing object is necessary because remember, when we will be constructing the prediction pipeline, the prediction pipeline essentially handles input data from the user. So that input data needs to be preprocessed, similar to the way we processed our training data. So that's why we are saving the preprocessor objects. So that means when we are building the prediction pipeline, we will load this preprocessor object. So this way that I like saving the preprocessor object. I'll be using the job lib. So I like using job lib because it saves a lot of space than the pickle file. So we are saving the preprocessor object. Then we also need to save the transformed data. So we need to save the transformed data. That's the training, testing, and the validation data. So we'll be saving this as not using a numpy files. I'm using .joblib. So we are going to save the transformed data. So we are using joblib. So after this, so we state, I think, where we are going to save. So we state the path where we are going to save our transformed data. Then we specify the name of that file. So for example, for the xtain transformed, we will be saving that as xtain transform.joblib. So the file will be a joblib file. For the validation for the xtest, so these are just the file paths. Then we use the function joblib.dump to now save these files in the respective folder, the root directory. Then after that, we return. We can return. So here we return the xtain transformed, xval transformed. I'll also want to return the preprocessor path. So we are going to return the xtain transformed, yval transformed, xtest transformed, ytrain, yval, ytest preprocessor path. So all these are the artifacts. Then after this, remember, accept exception as E, then erase E. That's okay. Then after that, the if block. So the if block, again, we specify if name underscore name underscore main. So we initialize the configuration manager, so config. We'll just call it a configuration manager. Then we get data transformation configuration. I think that will be data transformation config.get transformation config. So that's okay. Then after this, we get the data transformation. So data transformation config, okay. Then this we split. I think it will be the splitting process. So that will be xtrain xval. So train val test splitting. Then this will be now this one here, where we return all these objects. So there's something I'm missing. Xtrain xval. Something I'm missing, supposed to be xtrain transformed, xval transformed, xtest transformed, ytrain, yval, ytest, y preprocessor path, then slash data transformation, initiate data transformation, xtrain, xval, xtest, ytrain, yval. Yeah, I think it's okay. Then from here, maybe you can also use the try. Then just okay. Then accept exception as E. Then logging error, raise E. Okay, I think this is now okay. I'm going to, in our terminal, let's execute this transformation pipeline. So just copy the relative path. Python experiment trial 3. Make sure you have saved everything. In terms of dependencies, do we need, I think we updated the params.yaml, but params.yaml don't need this in the data transformation. It will be important during the model trainer. So that's not a problem. Schema, I think we updated this during our data validation. Yeah. I think so. No. Config.yaml, I think, yeah. I think everything is okay. So let's just execute this one. So what should be the result from this? We need to, under artifacts, we need to create a new folder, data transformation. And in this data transformation, it will be housing our, first, we need to see that where is it? We need to have our ytrain, yval, ytest. So this will be under our data transformation directory. Also, we need to see our preprocessor object, and also under the data validation, we need to have the xtrain transformed, xval transformed, and the ytest transformed. I think we are getting an error. An error occurred during the data transformation. X does not contain columns listed in calls. I think this is E. And get transformation object. Does not contain columns that were listed. X does not contain columns listed in calls. X does not contain columns listed in the config.yaml. So let's just counter check. Data transformation root directory. make sure I have every column, categorical columns. So that one is okay. So under data transformation, so categorical columns. So categorical calls is a list. Then don't think we have a challenge here. Categorical calls supposed to be yeah, that one is okay. Then class data transformation, numeric categorical self. Okay. Pipeline steps. So where was the error coming from? Let's see. So here there is data transformation, get transformer object. Fine. Yeah. Transformation calls, categorical calls, or don't know why. Let's try to do away with this. Categorical columns. Categorical columns. So target encoder, categorical target. This one target encoder, calls. Okay. Let's try to run this again. Line 306 values. But you can see again we are getting the same error. An error occurred during X does not contain the columns listed in calls. Categorical columns. So then the don't know why 1330 to the error itself. 185, 164, initiate data transformation. Yeah, I think now everything is okay. I think the error was coming under the get data transformation object, this one here. So what I just did was to do away with the imputation. Let's see if it will work again with that. So I've just tried to do away with the simple imputer strategy most frequent. Let's see if we'll get, would wish for that to be present in the imputer, this one here, the categorical columns. I would wish that to be present. So let's see if it will work, because I've just included it. The categorical transformer. Yeah, I think it's, yeah, you see that was the reason. You can see X does not contain columns listed in calls. So that was the reason why we were getting an error so I'm just going to remove that and just remain with the target encoder. Don't know if it will allow us to add other things. Int 0 calls boolean, true, 100 missing values, unknown. So let's just work with the way it is. Get encoder, we can specify. Let's assume this one is not present. How will this behave? Oops, just use that one. Or let's try to be it's okay. Imputer strategy. I think this will just work okay. Categorical transformer, steps, target encoder. Okay, I think this will just work okay. So let's delete the data transformation. This one here, just delete this. Then we can run the data transformation again. So with the slight changes that we have made, I think it will run okay. Once that is done, then we need to start converting our trial into a modular coding. So we start again with the entity. So config entity. I think this will be successful. Start with the entity. So this is the data transformation entity. This is the data transformation entity. Just copy this. Then config entity. Just specify data transformation entity. So that's okay. And save it. Then we also need configuration manager. This is a constant. We'll just copy this one here. So then we go to our configuration manager. Where is the configuration? So data validation. So this will be, let's copy that first. So this was the data validation. This will be data transformation config manager. So that's okay, data transformation. So we are done with that. The next will be after config, configuration manager. Then we need to go to the entity config components. So data transformation, just copy everything, go to the components, components data transformation, just adjust paste. Then this one is unnecessary. the configuration manager. Again, config manager, this is unnecessary, and also the transformation entity, that's unnecessary. But remember, we do need to import the data transformation config. So I'll say from src.churn. So we are importing the configuration that comes from config entity. So .entity config entity. We're going to import data transformation config. I think we are missing something. .churn, supposed to be .churn, .entity. Yeah, that one is okay. Then we don't need the data class, don't need path, don't need numpy. Don't need create directories. Save object, we need it. This one we don't need it, so that's okay. Minmax, yeah. So I'm just doing away with the modules that are unnecessary for this, for running our data transformation component. So let's counter check to see if everything is okay. I do believe we are good at this up to this point. So that's okay. So components done. So the next thing will be the pipelines. So data transformation pipeline. For the data transformation pipeline, at first we import the necessary libraries, config manager, the component section, then logging. OS, I don't think we need it. So path JSON. So we name the transformation pipeline. So this will be, give the name of the pipeline. So this will be the data transformation pipeline. So we create a class for the data transformation. And for the data transformation, as you can see, I'm chaining this with the data validation. So we need to make sure that our data validation, for example, we were returning, validating all the columns, validating the data types, and also validating the missing values. So all this needs to be true, so that all this need to be true for us to run the data transformation pipeline. Okay. So we are first reading the JSON file. So we are opening the JSON file and we are checking if all status are true. If that is okay, then we just log this information. The data validation pipeline has already executed successfully. Then we start now with the data transformation pipeline. So config data transformation config. Then we do the train val test splitting. Then we initiate the data transformation part of it. Then we can store our data in the artifacts as provided. So, okay. So that's the data transformation. As you can see, we're just chaining that with the data validation. So after the pipeline, then we go to the main.py. So here's our main.py. So main.py, this one. So under the main.py, here we again we create component number 3. Component number 2 is data validation. So component number 3 will be the data transformation component. So we need to import the data transformation pipeline. So again, we are going to say from src .churn pipelines. So this will be pipeline number 3, data transformation. So we are going to import data transformation pipeline. So I think that one is good to go. Data transformation component. Okay, so after this, the only thing remaining is to execute the main.py. So Python main.py. So before we execute this, just confirm that you have saved everything to avoid raising an error. So main.py. So the pipeline is okay. The configuration, again, this is okay. Params, this one will work on it when we reach or when we are sorting the model trainer. I think everything is okay, so can just main.py. So this one with the main.py, essentially we are going to start. We'll start run the data ingestion component, then the data validation component, then the model trainer component. So this is just a way to ensure that all these processes are executing successfully and simultaneously. Okay. So starting with the model data ingestion. So you can see this one is for data ingestion. Data ingestion started. Starting data ingestion collection for the so that's you can see. So the data ingestion is okay. See the records as we are ingesting our data, about 10,000 records per cycle. Then we can see our data validation component terminated successfully. Data validation component started, terminated successfully. And we can see for the data transformation, you can see that the data validation pipeline has already executed successfully because remember we are chaining those two together. Then you can see the data transformation component terminated successfully. So I think that one is okay. That's it. So that's it with our data transformation. So most of the time I do think that sometimes a data transformation involves complex data manipulation steps. So for my case, I think most of those heavy data transformation sequence should be for my own opinion, I think should be conducted outside the model. So such that inside the model, just simple stuff like simple things like these pipelines, column transformer and all that. So inside the data transformation should be just things like splitting your data, doing the preprocessing and all that. So simple stuff like this should be inside the model. But for example, I think I'm getting what anyway. So that's it. So I'm just going to push this code to a Git repository. So git add git status the code. So these are the files that we modified. So git commit -m. So this one you can say git commit. So data transformation complete. Then from here we can say git push -u origin to main. I think that's it. So that's it for this session. I do hope if you haven't subscribed to the channel, please do so before we sign off. Also, I will see you in the next one where we start on the model training. Okay. Then I think by that will be remaining the model evaluation and the model validation. Okay, so see you in the next one where we start with our model trainer. Bye bye.